Yes.
Can you see
You can
my
go
screen?
ahead. Yes, you're good to go, Mazz.
Okay. So we're looking at the UI page for the graph, and I'm going to, I have Istio's book info demo installed and running. I got some data. So you're going to see I'm going to select the namespace where I installed the book info demo, which is here. You're going to see that we've got our graph that shows the nodes, edges, and we've even grouped the services, the review service and all its versions here. One thing to note is that as you hover over the items, they're going to be highlighted based on what you're focusing on. So here you can see I'm looking at this edge, so I can see the edge and it's the two microservices connecting that connection. Similarly, if I go to this group, you can see it's highlighting all the relevant or related nodes and edges of this grouped service. So you can see my versions 1, 2, and 3, all the incoming and outgoing requests and what microservices are talking to it. So that's what this flashing is doing. All right, so if I click a node, this microservice here, product page, you're going to see the raw data here in a table. We've got some pie graphs. We're not sure exactly what to show in this pie graph yet. Right now, it's just success fail. We may split this out into the 3x, 4x, 5x. And you can see our Spark graphs of the individual data. I have no errors. I didn't force any errors here. That's why you see the red bar there. The time frame is based on this selector up here. I'm looking at 10 minutes worth of data. This links to our services page over here. I'm not going to click that. That's what Lucas will show, but that's what that's doing. Also notice when I click a node, I've frozen the highlighting so you can see whatever I'm selected on. I'm focusing on this microservice and you can see all the incoming and outgoing connections and the microservices that are associated with that. If I click an edge, again, you can see I've just highlighted what's related to this connector. I can see where this data is coming from and where it's going to, and you can see the data is reflected over here of the source and destination of this connection. And again, it's data and the last 10 minutes worth of data here. So if I click another edge, you'll see the data changes on the right side. And notice how the highlighting changes, right? So now I'm focusing on this, on these product page and the review version 3, because that's the edge I'm looking at. If I were to click on this group box, now we're going to look at some aggregates here. So here I'm looking at the review microservice, but grouped by version 1, 2, and 3, so I can see all the data coming in to those different version microservices, where it's coming, where it's going to, where it came from. And this is all the aggregate data of all these edges here. And again, it's the same raw data up here and the Spark graph up here with the aggregate data. And here you could see labels of what versions make up this group. Okay, the final thing I wanted to show was the different types of graphs. Right now we're looking at the Dagre format of the graph. We have different ones. We don't know what we're going to keep, what we're going to throw away, but the idea is we just wanted to be able to show different versions. So here's this breadth first. I'll just go through all of them. Some of these are good, some of these I think are not so good. We'll get rid of the ones like, we can also zoom in, zoom out. We've already seen that Dagre one. This one I'm not too crazy about. But the point is, using the Cytoscape library, we can change the different layouts however we want. We can get rid of some of these. We can focus, only keep one. But that's what we got. All right, that's it.
Okay, Lucas, you're next. You can just share your screen. Yeah, we see it. Thanks.
Hello, can you hear me?
Yes.
Okay, thank you. So what I would like to show you in this demo is the improvements that we are working on related to the services details pages. So clicking on the services menu tab, so what we can get here is all the services deployed into the system, okay? So we can select by namespace. For example, in my machine, in my environment, I have the book info and the Istio tutorial deployed in the system. And we could also, for example, do more specific filtering just for namespace or just specific services, right? So one of the things that are new for this new sprint is that we are bringing some status information as a summary in the services. So in this case, we are showing for a deployment, for the reviews deployment, what are the desired pods and the desired replicas and what is the available replica. So in this case, it's green because we are matching the desired replicas that we define in the deployment. Clicking into the details, so what we can see here is that we improve the information, detailed information about the services. We are bringing, for example, in the summary of the description, the labels, information for these particular services, the ports that are related, endpoints, and the pods that are attached to these endpoints, and also specific metrics at the overall health. This health metric came from the Istio Envoy proxy. Basically, the same concept of health that Istio Envoy is working is what we are bringing here. We have improved the information that we show. Now we are focused to show the deployments that we have for these services. So in this particular services, we have 3 versions, and we can see how many replicas do we want for each particular version. We are also showing what are the source services that are related for this particular services, because this is important information to understand what are the potential traffic Istio RouteRules that we can define, or the destination policies for this particular service. So in this case, in the case of the review, so what basically I've done is just to follow evaluate the info or post tutorial with all the examples of adding new intelligent routing. And the goal was try to show that all the new route rules that you are creating into the example have now visibility into the console. In this particular example, what I defined 2 new route rules. For example, we can see this preliminary rules, all the details that is the high precedence. So it's going to match into the cookie for a particular user, and for this particular user is going to route all the traffic into the version 2. And for the regular traffic is going to wait all the incoming for version 1 and version 3. Okay. Also, we will show that we support now destination policies in other services. But I want also to show to you that we have improved the metrics details. So now we can see the details for this particular services. We can show all the incoming and the output traffic for the request volume, request size, request duration, etc. So we have started to add some capacity to define what is the duration, what are the ticks, the rate interval that we want to show. And also interesting one that we can add some grouping by versions. For example, the review services has several versions, and we can just get these details of for this particular one. And we haven't missed that if this information is not enough, we can also link optionally with the Grafana dashboard also to show the details of the metrics of these services. In addition, we can also, for this particular services, we can integrate with the traces. So we can click here and we can just go into the specific trace details for the reviews one. So I won't enter to that because I guess that Juca is going to explain later more detailedly this one. Another interesting thing is that we have increased the coverage of all the types of Istio rules type that we can support. For example, if we go to in the filters and we go to the recommendation, sorry. So in this new services, in the tutorial recommendation services, we can to show how in this one I define 2 destination policies, one with a simple circuit breaker with all the details for this circuit breaker, what is the destination version that is linked with, and also what are, for example, what is other rule, what is the destination, the source, and the load balancing policy that we want to show. Another new thing that we can show is that we started to add support for Istio Mixer Rules. Okay, Istio Mixer Rules are specific rules that may or may not be linked with a services. For example, when you define new quotas, when you define, for example, new chains into metrics or whatever. So now we can to give support to show this in the console. For example, we can see here some of the default ones that are under the Istio systems. This is particularly interesting because, for example, when you create a new quota, the quota rule for this one is defined into the Istio system. For example, in this case, we have started to figure out how to model this information. In this case, we have this Istio Mixer rule with we didn't have any kind of match, so we can to show we have an action with a handler, with a main quota, with the details of this main quota, and we have the instance from some templates. This is the template from this one. So as commented, we may have some Istio Mixer rules that are generic to the whole system, with the Istio system, and we may have others that are specific for a particular namespace. For example, in this case, if you try to add some policy Istio rules, there are focus on the tutorial namespace. For example, this one to check from customers. They have a specific match from this, and we may have what is the blacklist that I want to do here, and what is the specific details for the instance that we want to show on this one. We are still working on this rule, so the idea could be in following sprints we can link this information with the services when we have the information how to link or to maintain here in order to query this info. And I guess it's done for me.
Okay, thanks, Lucas. Juca, I think you're next.
Yep. Can you see my screen?
We see that you are sharing your screen, yeah?
I'm sharing my screen, yes. You guys are supposed to see my terminal at least.
I just see no blue jeans.
Oh, then I'm sharing the wrong screen. Can you see a terminal now?
I still see blue jeans, but
I see it.
hold on. Yeah, I think it's.
I saw it. There we go. Got it.
Yeah.
Okay.
Good night.
Okay. Cool. All right. So yeah, my demo is quite boring, especially for those who know Jaeger and open tracing already. I mean, the target for this demo were people who have no previous exposure to the concepts of distributed tracing and especially Jaeger and open tracing. So what I have here is a set of services. So one front-end service written and deployed on Spring Boot, and the second microservice is a Java EE application deployed on Wildfly Swarm, and the third is a Vertex application. The whole idea of the demo is a drone delivery service. So a user would tap a button on a mobile phone or click a button on a web client, represented by the front end here. That would make a request to the backend. The backend would pick one drone from the cache and dispatch to the user's location. So I have here Jaeger running on a Docker container. I have Prometheus running on my laptop, on my bare metal. Then the front-end application is running already to save some time. And I have here the backend and the drone. So I planted some thread slips on my code here to simulate some performance bottlenecks, some delays. And I would like to find those places. So I'm just going to run a request three times and hope that we see traces on Jaeger. So we have 3 traces here. So let me pick one of those. And yeah, so this is the request as seen by Jaeger in the form of a trace. And we see the 3 services being called here, each service with one caller. And it always starts so this is the first part of our system, which is touched by the user. And this is at the web servlet layer. So this is the front end. Again, this is a Spring Boot application. And with the Spring Boot integration, we are able to get also logging information and some metadata about the request. So what is HTTP URL and HTTP method and so on and so forth. We have 4 spans for the front end. The last one being Zool. So Zool is an API gateway or a proxy that is usually used with Spring Boot applications to abstract the backend, right? To abstract what is a remote counterpart. So that means we have a integration with some components which are commonly used in Spring Boot applications. Now then we have the backend. Also, it starts at the web servlet layer, also recording the URL and a method, and the final point on the backend is on the WebSocket. So the WebSocket is an EJB bean as well. It is a WebSocket, a regular WebSocket plus an EJB. This is where we pick one of the connections from the pool or from the cache and send then a message to the drone. Now, the communication here, the span propagation is done manually because we don't have integration between we don't have integration for WebSockets on OpenTracing yet, and same for Vertex, so we have to do the context propagation here manually. But everything else is quite automatic. So this is the point where I would ask you if you could guess where the performance bottlenecks are, but to save some time, I'm just going to tell you it's here. And I'm just going to open the locator service, EJB. The other one, you can guess it's here. Let me open the class, and indeed we see the thread slip here. I'll just then restart the backend Swarm, and I have to restart the drone as well because I have not done anything related to resiliency, so the drone will just not have the connection to the backend. Now, while the backend starts, I want to show you the code for the front end. So if I remember, we had 4 spans on the front end. The front end is a Spring Boot application, right? And but we have no code in our business classes. We don't have anything related to OpenTracing or Jaeger at all. So what we have, so just to preview, so we have 3 classes, and none of them we have OpenTracing API or OpenTracing integration at all. What we do have, though, is 2 more dependencies on the build file, and one of them is the OpenTracing Spring Cloud Starter. And the second one is the Jaeger tracer resolver. So the first one is a set of auto-configure beans for Spring Boot, and that means so the components we provide wrap the actual operations on Spring Boot, meaning we are able to place a span around a request or around an outgoing Zool request, for instance. The tracer resolver is uses an open tracing API to advertise itself to the open tracing, right? So whenever a user asks for a current tracer, the open tracing API can just get what are the current valid tracers on the class path, and in this case here, Jaeger will just say advertise itself. And in the end, it means that the application would not need to know that Jaeger is there at all, right? So an application will not need to instantiate the tracer, the Jaeger tracer or anything. We just need a couple environment variables to set the service name, for instance, and that's it. Yeah, so the other thing that I wanted to show in this demo is, so we have 3 places on the backend where we are aware of open tracing and or Jaeger. One of those places is here on the tracer initializer. And I have a Jaeger tracer, and that is decorated by a Prometheus tracer. That means that whenever a span is reported, the data reaches not only Jaeger, but also Prometheus. So that gives us a 2 views of the same data. So one is the story of a request on Jaeger, and then we have the story of all requests in an aggregated way in Prometheus. Right. So yeah, we have here. So we have the individual traces here, one for each request, and then on Prometheus we have a list of spans that as data points here on Prometheus, which means we can combine this data point with data points with whatever else we have in our infra, and perhaps even having this data on a Grafana dashboard, perhaps create an alert when something happens. Yeah, so Prometheus is one way. I mean, once it is in Prometheus, it can be consumed in several different ways. Now, just to conclude, I just run the curl commands 3 times again, and then just see how different the trace looks like. And one last thing to mention is that this is the original request from the user, and it took 23 milliseconds. But in Jaeger, we can clearly see that this is not the whole story. So that request triggered some business process here that outlived the original request. Right. So we can see the consequences of the original request on a trace view like this. And that concludes the demo.
All right, thanks. It was a bit fast. I hope everyone could follow, but yeah, that concludes the Sprint 2 demo. Kiali. Let's go to yeah, the 3 small demos connect to each other. You can see the graph, and you click a service, you get more detail of the service, and then in the service you have access to find out like separate Jaeger UI where you can dig into the distributed trace, find out your bottlenecks, shown that it doesn't require a lot of instrumentation if you don't want to put more instrumentation, and that it's multiple service, multiple frameworks, so Spring Boot, Swarm, Vertex here, which is pretty cool. So I stop the recording.